Hi, this video is the continuation of the video where I was trying to fix the power board from an air conditioning pack. I took out the board and then I have removed a Zener diode. In this video there might be a little bit of a mishmash in cuts because I did not know in which direction the journey will go and how this will end. But let me show you what happened and what at the end the solution was. I've got the Zener diodes delivered which I've ordered, so they are the same rating, voltage rating like that one, which is not working anymore from the air conditioning main board. But you see, these are the typical Zener diodes like you can get it now. The rating is 1 watt and you see how the original one is. I could not find any information about this through hole diode, how many watts this one is rated. But so my plan is now to use 3 of these ones instead in parallel. Why do I think that I can do this? Well, what I have learned now about these Zener diodes is we are not pushing the whole current above these diodes. They are acting more like overflow valves. So when the voltage is too high, they will open up and drain some current through the diode. I think they can only carry current as much they are rated for. So if that is not enough, it will probably only result in a not as nicely draw down voltage. But I don't think we can overload the diode. But we will find out, I think. What I want to do first is, as you know, where the most of the current went, probably the solder mask peeled off the copper trace. So what I want to do, I want to protect the trace and put flux on it, and then I will put solder on it. So let me do that first. So I just put a lot of flux on the copper. Now I'm going to apply the solder. Okay, so now I think the trace is a little bit better protected from the humidity. I will now clean out these pins where the Zener diode was, and then we will put 3 of the new Zener diodes instead of the old one. Just take some flux and then we will use the wick. The holes are free. So let's take 3 Zener diodes. I think we can put 3 into one hole already. Okay, here's some close-up how this looks like. The board is inside here again, and you see the diodes are very fine in the back. They're protected here behind the plastic. So if they blow up, they will not blow into our face. So I will power up the AC, and then this connector here, I will try to measure it. This one here should be plus, and then the next 2 pins are ground. So if you have a voltage there, then we can try to connect the other pieces here. I have measured this one, and there is 310 volts DC on that one. So this is because this is the connector of the motor of the air condition, and this is using high voltage DC. The low voltage will be here on the down, so I will try to measure if here on those points which are marked 12 volt, 5 volts, if I can measure some voltage there. Okay, let's just talk quickly why this board is a no fix without even trying to continue further than exchanging these diodes. The main problem of this board and why it's not DIY friendly is because this is a high voltage DC board. So we are getting 230 volts in here AC, and then it goes into a transformer, and the transformer is actually not stepping down anything. This is just isolating AC side from later the DC side. So the output of this transformer is still 230 volts. Then it goes over this bridge rectifier, and what is coming out from there is 380 volts DC. That's why I was wondering, why is this capacitor here rated for 450 volts? Because it needs to be. This here, this connector is going to the motor, the fan motor of the inside unit. And the fan motor of the inside unit is a 400 volt DC motor. So all this board here, including half side of this inductor, or it can only be inductor because there is no AC anymore. This is DC side is high voltage DC. So also these Zener diodes, they are just taking down the almost 400 volts DC by 5 volts to supply something here. There's a small IC here, and probably it is supplying that one with 5 volts, but the potential is coming from a high voltage DC. So on the other side of the Zener diode, there is still somewhere around 375 volts or something like that. If you're working on a board like this, if you touch any of these wires here parts, you will get a big zap. That is also the reason why our lizard had no chance of survival, because he touched here the almost 400 volt DC, which is going to this pin. Okay, so that's why I don't know how this other side here is then getting its low potential DC. It has to do something with this inductor, and then on the other side there is some voltage regulators, but on that side is dead, so I cannot measure any of these 5 or 12 volts which is written on the board. So somewhere in between high voltage DC and low voltage DC, there is then another problem, and I'm not continuing to search for this, because, as I said, if you accidentally come into contact of any part here, you will be in contact of 400 volts DC, and that is not a good option. I've ordered a new board from an online store. It costs $50, and when the board comes to my place, we will just install the new board and see if the unit is working again. Okay, so that is the explanation why this board is going to my spare parts and not further than that. Okay, I have got a delivery. Let's look what's inside the package, and yeah, it is the new power board for the air condition. So let's take this and install it, and then we want to try the pack if everything is working again. And now I have to show you something. So we have the two boards, this one the old one, this one the new one. We have the same serial number here, you see, but there's a difference. look at this connector and this connector. So this board has been produced 3 years ago, this one now, and they have obviously changed something on this. Everything else is identical, except here is one component and here is a light. I don't know what that is, but yeah, this sucks because my plug is for the big one and it of course cannot fit into this one. But if we look the back side of this, this is still the same PCB. So here these pins are not used. So I think I will just take the bigger connector and put it on this board here. There's another small change here next to this diode. Here on the old board there's a resistor, and on the new one that spot is kept empty. So this sucks again, you know, but anyways, I will try to change it, and then I hope this can be fixed that way. I've got the 2 connectors undamaged off the board. How did I do that? So I really used a lot of solder and soaked the connector from the back, and then I heated up all pins at one time with the soldering iron, and they came off. So very important to do that. Use a lot of leaded solder so that the melting point is lowered far enough and you can keep the solder flowing while pulling the connector out. Okay, I will now clean out the holes and then try to put the big connector here on this board. Okay, the connector went in now, and I will now solder the pins. Okay, the connector is in place. Now I'm going to remove this resistor here from the old board and put it here on this place where it's not present at the moment, and that would be all differences what I found on this board. I have not transplanted these 2 components from one board to the other, and now we are going to try to install this again. The board is back in, the connectors fit now. Let's try and switch this thing on. Look at this, guys, it works again. We did it! Wow! This was not expected, that we will really have to do some board repair in some sense, but wow, luckily everything else fitted and was same as before, and the board, especially the PCB, was not changed. All the holes were present, and wow, we did it. Very nice. Here the air conditioning is repaired, it is working. In the meantime, heavy rain has started. Yeah, we have been successful, and that is the important thing on this, and the lesson we have learned. So maybe not that everything can be fixed on a board, or everything should be fixed, because in this case this power supply is non-standard. It's a high DC power supply, and it's not safe to work on this. But changing a connector, even this should actually not be necessary, is possible, and we have been successful at the end. Hope you have found this process here also interesting. Please like the video, comment if you have anything to share. Please join our community, subscribe to the channel, and I see you next time.